Welcome to Lab to Fab Insights, bringing you the latest on the key issues shaping the future of semiconductor test and measurement. I'm your host, Paul Swangard, and I'm here with FormFactor's Giancarlo Di Chirico, who is a marketing director and is involved in the company's wireless communications business. He's going to share his insights on the key trends, challenges, and solutions for testing in 5G and 6G semiconductors. Welcome to the show, Giancarlo.
Thank you, Paul. I'm really glad to be here.
Well, let's get started. There's no doubt that the emergence of 5G created a world of possibilities and test headaches when it emerged. Technologies like autonomous driving, virtual reality, and IoT exploded with possibility, along with the telecoms aspect. Now, how has 5G and the impending emergence of 6G changed the world of semiconductor test?
So 5G's true value is its extreme reliability and ultra low latency. So the delay between sending and receiving information, which could be as little as 1 millisecond. So this will make possible all sort of enterprise applications that couldn't operate via cell networks before, which will mean a massive increase in the number of connected devices operating on the network. So the 5G speed is great with data rate up to 20 gigabit per second, higher traffic capacity with 100 times increase compared to 4G, and many more devices connected to the network, as I said. So higher density, that means higher density. But many mission critical applications simply cannot trust the current network's reliability. And so with 5G's reliability, those concerns largely disappear. So you see 5G creates a faster ecosystem and an ecosystem with many more devices and applications, ranging from telecommunications, healthcare, automotive with automotive radar, and vehicle to everything communications, aerospace and defense applications like new space, electronic warfare, and industrial to smart cities.
Can you describe some of the trends and the challenges associated with testing devices for the 5G and above?
So as a trend, the front-end devices for cell phones is very high growth rate, of course, with many power amplifier modules, front-end modules, low noise amplifiers, so LNAs, switches, filters, and devices like that. They are manufactured not only on silicon, but also on gallium arsenide and gallium nitride. And these devices will have to work at higher frequencies with 5G and even higher with 6G. So with many more semiconductors and ICs to test, the importance of device modeling is increasing and is becoming fundamental to build accurate process design kits for the IC designers and engineers. So one of the most important challenges is to achieve faster time to market for them, while having more accurate, stable, and repeatable data of these devices.
Now, can you describe what you'll encounter with the higher frequencies in mobile communications, radar, and next-gen Wi-Fi standards?
Yeah, so looking far down the road, basically 6G is expected to merge communications and sensing in a new way. And wide bandwidth needed for data will also benefit many high precision sensing applications. So as the next decade unfolds, even richer multimedia applications in the form of high fidelity holograms and immersive reality, tactile and haptic-based communications, as well as the support of mission-critical applications for connecting all things are being discussed right now for consideration.
And what problems do you anticipate encountering with 5G semiconductor testing?
Our customers want more data to help create better models and the corresponding demand for more throughput. Therefore, reliability, puts a high demand on testing. The IC designer can simply afford multiple design iterations because this could be caused by inaccurate device modeling and simulation. And so what they need to do is to have a faster and more accurate on-wafer device characterization to build up a more accurate process design kit. And this requires test equipment with broadband frequency capabilities. We anticipate difficulty in making high frequency calibrations and measurements, especially when tested devices over temperature, because the vector network analyzers, frequency extenders, the probes, the waveguides, all the components are going to expand and contract over temperature with temperature. And so this is going to affect the calibration and will lead to more time-consuming calibration processes, delaying the time to market for the ICs.
You've described a situation where test methods haven't necessarily been developed. After all, the complexity, the speeds, the demand for high reliability devices have never been greater. So where do you begin to start developing a test strategy?
Well, first of all, you need to create an integrated solution that includes hardware, probes, and also software. So there's no single vendor that can do this job. And so the first thing you need is to bring in world-class solution partners. And FormFactor's brought in partners like Keysight, Virginia Diodes, and Dominion Microprobes. With these partners, we can configure a system that provides a solution that can get the customers the best dynamic range, the highest level output power, greatest stability for efficient broadband device modeling and characterization of on-wafer devices for both next generation 5G and future 6G technologies.
Okay, so you've assembled all the pieces to approach this testing. What will you be looking for as you test?
So we need to make sure that the probe placement is really dead on accurate. We need to make sure that there's no drift affecting the customer's measurements. And also maximizing the throughput is paramount to bring the IC to the market. So companies need to take advantage of their investment made in the test equipment. And so they need to test even overnight and over the weekend to maximize their test equipment. So the use of their test equipment. So this means that unattended testing with auto-loading wafer capabilities and with must-have capabilities like automated and autonomous monitoring and recalibration. So they're really required for them. You're going to need to test over a wide range of temperatures, and the ability to do this 24/7 is mandatory, as the throughput is very important, as I already mentioned.
All right, Giancarlo, I'm going to put you on the spot. Walk me through the system.
I like to be on the spot. So the system, like a broadband with broadband capabilities up to 170, 220 gigahertz, includes multiple pieces. So a single sweep solution based on a Keysight vector network analyzer is the M50291A, which is a millimeter wave system all the way up to 130 gigahertz from very low frequency, 900 hertz. And then the Virginia Diodes sub-terahertz frequency extenders. For this purpose, they have developed like extended range WR 5.1 extenders. So from 130 to cover from 130 all the way to 220 gigahertz. And then Dominion Microprobes broadband probes, they combine the coaxial and the waveguide signals all the way to the probe tips with an internal diplexer. And then last but not least, of course, all the FormFactor probe stations that come in many different flavors, 200 millimeter, 300 millimeter probe station, semi-automated, fully automated. And along with that, of course, you need to have like measurement over temperature capabilities with thermal systems that we do provide, contact intelligence technologies, which is a patented technology to enable calibration monitoring and recalibration, unattended use, and reduce soak times. Autonomous RF capabilities, we talked about that. Modularity probe arms to allow an easy band swap to swap between different probe arms. And also, of course, ISS, standards to make calibration, to perform calibration, and software to perform calibration tasks and post-processing tasks as well.
So can you just give us a sense of how difficult it is to integrate these components to create a successful 5G semiconductor test system?
Of course, yeah. So we've worked closely with our partners to ensure that the connection between all the components, were straightforward. And software integration is very important as well because it enables all the hardware capabilities. So we use the software to control the probe station and all the components, the various components, and a comprehensive software, like a comprehensive tool, an intuitive tool for wafer RF measurement calibration to achieve accurate and repeatable calibrations and measurements.
Giancarlo, thank you. I think we now understand the promise and complexity of what a 5G and beyond world presents to those tasked with testing the wafers that will provide those sophisticated devices.
It's been my pleasure, Paul. Thank you for having me.